All right, get ready to dive deep into human perception and action.
Sound exciting.
You've given us so much to explore, a ton of great sources about how our senses work,
Yeah.
from vision to touch,
Right.
to even how we experience pain.
Hmm.
I can't wait to unravel it all.
It's fascinating how we just go through life using our senses,
Right.
seeing and hearing, touching, feeling, and we don't really think much about how it all works, you know?
Yeah,
There's
totally.
so much more going on than we realize.
Okay, so what's one of the most surprising things about our senses
Hmm.
that people might not realize?
Well, a lot of people are surprised to find out
Okay.
how much our brains actually construct our perception of the world.
Oh, interesting.
It's not just about passively receiving information through our senses.
Okay.
It's about actively interpreting and making sense of that information based on our experiences and, what we expect to happen.
So our brains are like filling in the gaps,
Exactly.
kind of making educated guesses.
Exactly. And sometimes, yeah, those guesses can lead to illusions or
Oh,
misinterpretations.
sure, yeah.
But for the most part, this
Mm.
whole process of making inferences,
Yeah,
that's what makes our senses so amazingly efficient and accurate.
that's really cool.
Yeah.
All right, I'm definitely hooked now.
Great.
Let's dive into a specific example.
Sure.
How about speech perception?
Okay.
We process language at an incredible speed
It is amazing.
and understand meaning from this, like, constant stream of sounds.
Right.
Without even thinking about it. It's mind-blowing.
It really is. One of the key mechanisms at play is something called categorical perception.
Okay, what's that?
It's essentially how our brains simplify this complex stream of sound
Right.
by grouping similar sounds together.
So even though there might be tiny variations in the way a sound is pronounced,
Right?
our brains kind of categorize them
Yeah.
as belonging to the same sound?
Precisely.
Hmm.
Think about the sounds da and ta. The only difference is something called voice onset time.
Yes, I am.
That's how long it takes for your vocal cords to vibrate after the sound is released.
Okay.
But our brains categorize those tiny little variations as different sounds.
Wow.
Yeah.
I never even thought about
It's
that.
pretty cool.
It's like our brains are creating this simplified map
Yeah.
of all the sounds to help us understand language.
So that's a great way to put it.
Okay, that makes sense.
Yeah, and what's even more amazing is that babies under 6 months old
Oh, wow.
can actually discriminate between subtler sound variations than adults can.
So babies are even better at hearing those little differences.
Yes.
Why is that?
It's because they're still in the process of learning the sound categories of their
Yes.
native language.
Right.
Their brains are like little sponges
Right.
soaking up all those nuances before they focus on the
Yeah.
specific sounds that matter most for their language.
That's so fascinating.
It is.
So our brains are kind of fine-tuning themselves from a very early age
Yeah.
to the specific sounds we need
Exactly.
to understand the languages around us.
Yes.
Wow. But what happens when our different senses start to, like, clash?
Oh, that's where things get really interesting.
Okay.
Let me introduce you to something called the McGurk effect.
The McGurk effect.
Yes. This is a classic example of
Right.
how what we see can actually influence what we hear.
What?
There's a video that demonstrates this perfectly.
I am intrigued. Tell me more.
So in this video, you see a person mouthing the syllable ga,
Okay, got.
but the audio you hear is the sound ga.
Okay.
The crazy thing is, when you combine the visual information of ga with
Perfectly.
the audio information ba,
Wait.
your brain tries to reconcile those conflicting inputs
Wow.
and ends up perceiving the syllable da.
Whoa. That is so trippy.
It is, right.
Okay.
So it's like our brains are trying to make the most logical guess
Right.
based on the information from both our eyes and our ears,
Yeah?
even if it leads to a misperception.
That's amazing.
Isn't it?
It's like our brains are trying to tell us a story that makes sense,
Exactly.
even if it's not the accurate story.
Yeah, our brains love to make sense of things.
Okay, let's shift gears
Okay.
from hearing to feeling.
Right.
We all know what it's like to experience touch and temperature.
Mm-hmm.
But what's something surprising about these senses that we might not know?
Well, you might be surprised to learn that our sense of touch can be tricked really easily.
Oh, really?
Yeah, have you ever heard of the thermal grill illusion?
I think I've heard that name,
Oh, okay.
but I don't remember what it is.
It's a really simple but really powerful illusion
Okay.
that you can actually recreate at home.
Oh, cool.
All you need is 2 forks and some water.
Okay.
One fork goes in ice water,
Okay.
the other in warm water.
Right.
Then you intertwine the tines
Mm-hmm.
and gently touch them to your skin.
And then what happens?
Well, you would think it might feel lukewarm,
Right. Yeah.
but that's not what happens at all.
Ooh. You'll feel this surprisingly intense sensation of heat,
What?
even though neither fork is actually hot enough to burn you.
No way.
Yes.
Wait, so our brains are tricked into feeling burning pain,
Yeah.
even when there's no actual danger. That's wild.
It is, isn't it?
How does that even work?
It's a perfect example of how our brains use what we talked about earlier, sensory inference.
Okay.
They take information from those hot and cold receptors and combine it to create a perception of temperature.
Got it.
But in this case,
Yeah.
the conflicting signals from the hot and cold tines create a kind of sensory overload.
Oh, wow.
And our brain interprets that overload as intense heat.
That's amazing.
Yeah, it is pretty cool.
If our brains can misinterpret temperature like that,
Yeah.
what about other aspects of touch? Like how we control our grip strength.
Well, that's a good one.
Like how do we know how much pressure to apply,
Right.
especially when we're dealing with something, fragile?
That's a great question. Thanks.
And it highlights how remarkably coordinated our senses are with our motor skills.
Interesting.
It turns out that different types of receptors in our skin work together
Okay.
to give us information about pressure and even tiny bits of slippage.
Oh, that's cool.
Yeah.
So let's say I'm holding an egg.
Okay.
If the egg starts to slip,
Yeah.
even just a tiny bit, those receptors are sending signals to my brain.
Uh-huh.
And my brain then tells my hand muscles to adjust my grip
Exactly.
so I don't crush the egg.
Yes. It's this constant feedback loop between our senses and our muscles.
That's incredible.
Yeah, and it happens so effortlessly that we don't even notice it.
That is really amazing.
It is cool.
So we have this intricate system of receptors
Yeah.
giving us feedback about pressure and slippage.
Right.
Is our sense of touch equally sensitive all over our body?
That's actually a common misconception.
Yeah,
Our sensitivity varies quite a bit depending on what part of the body you're talking about.
Interesting.
It's related to something called the 2-point threshold.
Oh, yeah. I remember learning about that.
Good.
It's like the minimum distance between 2 points
Right.
that we can feel as separate.
Yeah, like on our fingertips, we can feel 2 points really close together.
Right.
Exactly.
Yeah.
But if we tried the same thing on, say, our calf with those 2 points about an inch apart,
Okay.
we might not be able to distinguish whether it's 1 point or 2.
Seriously.
Yeah.
Wow. I wouldn't have guessed that.
Yeah, it's kind of surprising.
Why is there such a big difference in sensitivity?
It comes down to the density of receptors in the skin
Okay.
and the amount of brain power that's dedicated to processing touch information from different body parts.
Oh.
Areas like our hands and fingers, which are so important for how we interact with the world,
Right.
they have a much higher density of touch receptors
Makes sense.
and a larger representation in the brain's somatosensory cortex.
It's like our brains are saying, hey, pay attention to the hands. Those are important.
Our hands are constantly exploring and manipulating objects.
Yeah.
So it makes sense that they would need this higher resolution of touch.
Right. It's all about efficiency, I guess.
It is. Our brains dedicate more processing power to the areas that need it the most.
That makes a lot of sense.
Yeah.
So speaking of sensations,
Yeah.
I've always thought about pain a bit differently,
Okay. How so?
especially as a runner. Pain isn't always a bad thing, right?
You're right. It's not.
Sometimes it's a signal telling me
Yeah.
to slow down
Yeah.
or that something needs attention.
That's a great way to look at it.
Yeah.
Absolutely. Pain often gets a bad rap,
Yeah.
but it's actually an essential warning system
Okay.
designed to protect us from injury.
Right.
It's our body's way of saying, hey, pay attention to this. Something's not right.
Like a built-in safety mechanism.
Right.
Yeah. If I feel a sharp pain in my knee,
Yeah.
it's like, okay, got to stop and figure out what's going on.
Exactly. And ignoring those signals
Yeah.
can lead to much more serious problems later on.
That's a good point, and I know that all too well.
Yeah.
But pain isn't always, physical.
Right.
What about those times
Yeah.
when we feel pain because we're empathizing with someone
Oh, Patricia.
who's suffering?
That's a fascinating aspect of pain called empathic pain.
Empathic pain.
Yes. It turns out that our brains can actually respond to other people's pain as if we were experiencing it ourselves.
Yeah, I've definitely felt that before.
Mm-hmm.
Like when you see someone trip and fall,
Right.
you wince,
Yeah.
even though you're the one who got hurt, you
Yeah.
know?
It's like you can feel their pain.
Yeah.
And there's actually scientific evidence for that.
Oh, really?
Yeah. Studies using fMRI have shown
Okay.
that when we witness someone else in pain,
Hmm.
some of the same brain regions light up,
Right.
as when we experience pain ourselves, particularly in the areas associated with emotional processing.
So it's not just a feeling, it's an actual neurological response.
Exactly.
That's wild. It really shows how deeply connected we are to each other.
Right.
On an emotional and even physical level.
It is a powerful reminder that we're social creatures.
Yeah.
And we're wired for empathy.
This deep dive is already blowing my mind.
Yeah.
And we've only just scratched the surface of
Sure.
perception.
We've got so much more to explore.
I can't wait.
Yeah, coming up next time, we'll explore how much of our perception actually happens outside of our conscious awareness. Get ready for some really mind-bending stuff.
I am ready. I'm so ready.
Great. Welcome back to our deep dive on perception and action.
I'm so ready for more.
Me too.
Last time we were talking about how a lot of our perception happens without us even realizing it.
Right.
Like outside of our conscious awareness.
It's true. It's like there's this hidden autopilot that's guiding our actions.
Okay. So can you give me an example
Sure.
of this unconscious perception in action?
Absolutely. Think about baseball outfielders catching fly balls.
Oh.
They're not up there like consciously calculating trajectories and angles.
Right.
It's happening on a much deeper level.
I've always wondered about that.
Yeah.
It seems almost instinctive, the way they move so gracefully to make those catches.
It really is remarkable.
Mm-hmm.
Research has shown that outfielders actually adjust their running path unconsciously to keep a certain visual relationship with the ball.
So they're not just running directly to where they think the ball will land.
No, it's more complex than that.
Oh.
Instead of planning out a straight path, they're constantly making these tiny adjustments, often running in a slightly curved path or even a circular path to keep the ball in a consistent spot in their vision.
That's amazing.
It is.
That makes those spectacular catches possible.
Exactly.
That's so cool.
It really highlights how brilliant our sensory motor systems are, even when we're not consciously aware of it.
So what other examples can you share about this unconscious perception?
Okay, let's talk about the Ebbinghaus illusion.
The Ebbinghaus illusion?
Yeah, those two circles that look like they're different sizes because of the circles around them?
Right.
It's a classic visual illusion that plays on our perception of relative size.
Oh, yeah, I remember that one.
It's easy to fall for it, right?
It is.
Our conscious perception gets fooled into thinking one circle is bigger.
Yeah.
But here's the fascinating part.
Okay.
If you are asked to reach out and grab the circle that looks bigger, your grip, the distance between your thumb and forefinger would be much more accurate than your conscious judgment.
Wow. So even though I might consciously see one as bigger,
yes,
my brain somehow knows the real size.
That's what the research suggests.
That's mind-blowing.
It is pretty wild, isn't it?
It's like there's a part of my brain that knows the truth.
Yeah.
Even when my conscious mind is totally fooled.
It really makes you question what you're seeing, doesn't it?
It does. It really does.
That's the beauty of studying perception. It challenges our assumptions about how the world works.
Right.
And it reveals just how complex our own minds are.
I love it.
Okay, let's shift gears a bit and talk about attention.
Right.
It's easy to assume that we see everything around us in perfect detail.
Right.
But that's actually not true at all. Our attention is very limited, and what we end up perceiving is largely determined by where we choose to focus.
It's interesting. I never really thought about it like that.
Yeah, a great example of this is the phenomenon of change blindness.
Oh, yeah. Change blindness.
Have you heard of that?
I have.
Okay, good.
It's where we miss big changes in our visual field.
Yes.
If we're not paying attention.
Exactly. Think about that famous gorilla video.
Yeah.
The one where you're so focused on counting basketball passes.
Right.
That you totally miss the person in the gorilla suit.
Yeah. That one went viral.
It did.
It's crazy how you can miss something so obvious.
Right.
When you're focused on something else.
It's a really powerful reminder that our brains are filtering information all the time.
Okay.
And we can be totally oblivious
Right.
to things that are right in front of us.
It makes you wonder how much we miss every day.
I know. It's a little unsettling.
It is, especially when you think about something like distracted driving.
Exactly.
We tend to think that as long as our eyes are on the road, we're good.
Yeah, but it's just not that simple.
Yeah.
Even hands-free devices can be a distraction
Right.
because they take our attention away from driving.
So are you saying that our brains can't really multitask?
They can't multitask as well as we think they can.
It's good to know, I guess.
Yeah, it's an important thing to remember.
So what's the key takeaway here?
Well, I think it starts with recognizing that our attention is limited. We have to be careful about where we choose to focus it.
Yeah.
Especially when we're doing something that requires a lot of concentration.
So it's like training ourselves to be more aware of where our attention is going.
Yeah, to be more mindful.
Make my mindful.
And resist the urge to multitask.
Gotcha.
Or get distracted.
Okay, now I want to talk about a sense that we often take for granted.
All right, which one?
Kinesthetic perception.
Oh, interesting.
It's that sixth sense, you know, the awareness of our body's position and movement.
Right, it's the sense that lets us know where our body is in space.
Exactly. And we use it all the time.
All the time.
Without even thinking about it.
We really do. It's essential for everything.
Yeah.
Walking, dancing, playing sports, even just sitting up straight.
Right. We don't have to consciously think about where our limbs are or how to move them.
It just happens automatically.
Okay, so break it down for me.
Sure.
What is kinesthetic perception exactly?
Well, there are two main components. Vestibular perception.
Vestibular perception.
Yes. That's our sense of overall body motion.
Okay.
And proprioception.
Proprioception, got it.
Which is the sense of where our individual body parts are.
Oh, okay, I see.
Does that make sense?
Yeah, it does.
So vestibular perception, that's what keeps us balanced and oriented.
Right, like if I spin around with my eyes closed, I can still tell which way is up.
Exactly. That's your vestibular system doing its job.
And that system relies on?
Okay, it relies on these fluid-filled canals in our inner ears.
No way.
It's pretty cool. They can detect any acceleration of your head.
Wow.
And that tells your brain how you're moving.
It's incredible how much is going on in our bodies that we're not even aware of.
It really is amazing.
Okay, so what about that dizzy feeling you get after spinning around?
Oh, yeah.
Is that our vestibular system messing up?
It's not messing up exactly, but when you stop spinning, the fluid in those canals, it keeps moving for a bit. And that sends these confusing signals to your brain.
But like it takes a second for our senses to catch up.
Right, exactly. It takes a few moments to reorient yourself.
Okay, that makes sense.
Good. So we've got this system in our inner ears for balance.
Right.
But what about proprioception?
Right, proprioception.
How do we know where our arms and legs are without looking at them?
That's a good question.
Well, that's where feedback from our muscles and tendons comes in.
Right.
And our joints, too.
Oh, wow.
Yeah, there are these specialized receptors in those tissues that send signals to the brain.
So our brain is getting a live feed from all over our body.
Yes. That's a great way to put it.
It's creating this internal map of where everything is.
Exactly. And there's this mechanism called efference copy.
Efference copy, okay.
It's where the brain makes a copy of the motor commands it sends to your muscles.
Interesting.
So that copy is compared to the sensory feedback from your body. And that helps us fine-tune our movements.
So it's like this constant back and forth communication between brain and body.
It's pretty amazing.
That's wild. Can you imagine what it would be like to lose that sense?
To lose proprioception.
Yeah.
It would be really disorienting.
Yeah.
There are people who have experienced this loss.
Oh, wow.
And their stories are incredible.
Yeah, in the outline, there was the story of Ian Waterman.
Oh, right.
Who lost his sense of proprioception.
Yeah.
But he was able to regain control of his body through sheer will.
It's amazing, right?
It really is.
It shows just how adaptable the human brain can be.
Right.
He basically had to relearn how to move.
Wow.
By consciously thinking about every single action.
That's incredible.
And relying on his vision to guide him.
Wow. That must have taken so much effort.
It must have. His story is a real testament to the human spirit and the power of the brain.
I love that.
All right, let's switch gears again and talk about babies.
Babies?
Yeah. For a long time, people thought babies were born with limited sensory abilities. Almost like blank slates, you know?
Yeah.
But research has shown that's not true at all.
Oh, interesting.
Babies are way more perceptive than we used to think.
Okay.
They come into the world ready to learn.
Yeah.
Using their senses to figure things out.
That makes sense.
And researchers have found clever ways to figure out what babies can see and understand.
Well, they can't exactly tell us, right?
Exactly. We have to get creative.
Right.
One common method is to track their eye movements.
Oh, that's interesting.
Yeah, by watching what they look at and for how long.
Okay.
We can get a sense of what they find interesting.
That's so cool.
It is, isn't it?
Yeah, like in that experiment with the moving light.
Oh, right. Yeah.
Researchers show a baby a light moving across a screen.
Yeah.
And they can track it with their eyes.
They can.
Which shows They can see and follow moving things from a very early age.
Even from birth.
That's amazing.
It is. And eye movements themselves are a really important part of development.
Oh, interesting.
Even though babies can make those rapid eye movements, like when their eyes jump from one spot to another,
right.
They can't smoothly track a moving object until they're a few months old.
Wow. So even basic motor skills like that develop over time.
They do. It's a combination of their biology and their experiences.
That's fascinating. Okay, now this is a captivating finding.
What's that?
From a very young age, babies seem to prefer looking at faces.
Yes.
Even though they haven't really had time to learn that preference.
That's right.
So does that mean it's innate?
It seems to be.
Wow.
Researchers have done these experiments using oval shapes and scrambled faces.
Yeah, I remember reading about that.
And even though the scrambled faces have similar features, babies consistently look longer at the real faces.
Actually, they're drawn to faces.
It seems that way.
That's incredible. So it suggests that.
It suggests that we're born with this bias to pay attention to faces.
Makes sense from an evolutionary perspective.
Definitely.
You know, recognizing faces is important for social interaction.
Absolutely.
And survival.
Yes. And it starts from a very young age.
So speaking of making sense of the world.
Yeah.
Those experiments with partially hidden objects are really interesting.
Oh, yeah. The ones where babies see a rod moving behind a block?
Yes.
Okay.
So they only see the top and bottom parts of the rod.
Right. The middle is hidden.
And then they take the block away, and they show the baby either a complete rod or two separate pieces.
Yeah, and what happens?
Well, the babies look longer at the two separate pieces.
Exactly.
It's like they expected to see one continuous rod.
It really does.
So even at 4 months old, babies are already showing perceptual completion.
It's a clear indication that babies, like adults, use inference to perceive the world.
They're not just passively taking in information.
Right.
They're actively trying to make sense of it.
That's exactly right. It's a really important finding.
It really challenges the old view of babies as just passive observers.
Yeah, they're actively engaging with their surroundings.
Wow, that's incredible. Seems like even from such a young age, our minds are always trying to make sense of the world.
That's a great point.
And speaking of making sense of the world, next time we'll delve into the fascinating world of illusions and magic.
I can't wait. It's going to be a fun one.
I'm ready. All right, I'm ready for my mind to be totally blown. Let's talk illusions and magic.
I thought you might like this part.
Yeah, I do. Visual illusions, I mean, they could be so trippy.
Right.
They make you question everything you see.
Exactly. And the best part is they often demonstrate those same principles of perception that we talked about in the last two parts, but in a more dramatic, more obvious way.
Okay, I like that. Can you give me an example?
Sure. How about the Canissa triangle?
The Canissa triangle.
Oh, you heard of that one?
I think so. Remind me.
It's that illusion where you see a bright white triangle, even though there aren't any lines actually forming that triangle.
Oh, yeah. I know that one.
Good.
Like 3 Pac-Man shapes in 3 angles, or V shapes arranged in a specific way, and your brain just like fills in the rest and sees a triangle.
Well, that's exactly what happens. It's a great example of what's called the Gestalt principle of pregnance.
Pregnance.
Yeah. Basically, it means our brains love simplicity.
Okay.
They want to see things in the simplest way possible.
Right. Less work for the brain.
Right. So instead of seeing 6 separate shapes, our brain sees one simple, coherent form, the triangle.
Even if it has to, like, invent some lines that aren't really there.
Exactly. And those lines are called illusory contours.
Illusory contours.
Yeah, it's our brain completing the picture.
It's like our brain is telling itself a story.
Is it?
It is.
A story that makes sense.
Yeah, a simple, organized story.
Even if it's not quite the whole truth.
Exactly.
Yeah.
And that's how a lot of perception works, you know?
That's fascinating. So is there another illusion that kind of shows how our expectations can shape what we see?
Absolutely.
Yeah.
Let's talk about the cafe wall illusion.
Cafe wall. Okay.
Yeah, you've probably seen pictures of it.
Yeah, maybe.
It's those rows of black and white squares.
Okay.
They look tilted.
Right, they do, even though they're not actually tilted.
Right, they're perfectly horizontal.
It's so weird how our eyes deceive us.
It's because our brains are really sensitive to contrasting edges.
Okay.
And they try to group things together visually.
Got it.
So with the cafe wall illusion, the way those squares are arranged, that slight offset and the high contrast, it tricks our visual system into seeing those lines as slanted.
It's incredible how like just the way things are arranged visually.
I know, right?
Can have such a big impact on our perception. It is amazing. Our brains are always trying to make sense of what we see.
Even when it's confusing.
Yeah, even when the information is kind of ambiguous.
Exactly.
And sometimes those attempts to make sense of things lead to these really interesting perceptual quirks.
Okay, speaking of weird quirks.
Yeah.
Have you ever heard of motion-induced blindness?
Oh, yeah, that one's really strange.
What is that?
Well, it's when moving patterns
Okay.
can make stationary objects disappear.
What?
Yeah, it sounds crazy, but it's true.
That's so weird.
There's a demonstration where you stare at a central point
Okay.
while these blue dots are moving all around it, and then these yellow dots appear.
Okay.
But they stay still,
All right.
and because of all the motion, those yellow dots can actually disappear.
No way. Something can be right in front of me,
Yeah.
and I might not even see it.
That's right.
It's like our brains can't handle all the information.
It's a great example of how our visual awareness is limited and how easily it can be tricked by motion.
So are you saying that what we see isn't always, like, the real truth?
It's not always an accurate reflection of reality, no.
Huh. That is unsettling.
Yeah, it is, but it's also fascinating.
I guess so, yeah.
Because it shows that our perception, it's not just this passive thing.
Okay.
It's actively constructed by our brains.
Right. We're not just cameras recording the world.
Exactly. Our brains are constantly interpreting and making sense of everything.
Right. And that interpretation can be influenced by all sorts of things.
It can. Our attention, our expectations, even how our brains are wired.
That's wild. Okay, last but not least, we have to talk about magic.
All right, let's do it.
Magicians are like masters of perception.
They are?
They use our brains against us.
It's true. They understand how perception works.
Yeah.
And they use that knowledge to create illusions.
Right, making the impossible seem possible.
Exactly, like when a magician makes a coin disappear.
How do they do that?
It's all about misdirection. They might use sleight of hand while we're focused on something else.
Oh, I see.
Or they might distract us with something flashy.
So we don't notice what's really happening.
Exactly.
That's so clever. It's amazing how easily we can be fooled.
It is. Even when we think we're paying attention,
Yeah.
it shows how powerful suggestion can be.
Right.
And how good our brains are at filling in the gaps to create a story.
Even if that story isn't real.
Exactly. And that's why magic is so much fun, I think.
Yeah, it's like it plays with our sense of wonder and possibility.
It does. It reminds us that there's still magic in the world, even if it's just a clever illusion.
I love that.
Me too.
So we've explored a lot in this deep dive.
Yeah, we have. From the inner ear to visual illusions to magic.
It's been quite a journey.
It really has.
What are some of the key takeaways you hope people will remember?
Well, I think the biggest one is that perception is active.
Yes.
Our brains are always working to make sense of the world around us. We're not just passively observing.
Right.
We're constantly interpreting and creating our own reality.
And that interpretation
Yeah.
is shaped by so many different factors.
It is. Our attention, our expectations,
Yeah.
even our emotions and past experiences.
It's incredible how complex it all is.
It really is, and I think it's so important to appreciate our senses
Yeah.
for what they are, incredible gifts.
They allow us to experience the world in all its richness and beauty.
And the more we understand about how they work,
Right.
the more we can appreciate the power and the complexity of our own minds.
This has been such a fascinating journey
It has.
through the world of human perception. Thank you so much for sharing all this with us.
Oh, it's been my pleasure. Thanks for having me.
Keep exploring, keep questioning, and keep being amazed by the incredible power of your own senses.